So good news, scholars, the rules we learned in the last section in 2.1 about how to simplify limit expressions still hold for when we want to let x approach positive infinity or negative infinity. So things like the limit of a sum is the same as the sum of the two limits. The limit of a product is the same as the product of two limits. So watch how we can use those rules to simplify something like this. This is from your textbook. If I want to find the limit as x approaches infinity of 5 minus 2 over x squared, I can split that up. That's a limit of a difference. Here's a difference. This is a subtraction problem. So I can simply take the difference of the two limits. So it's the same as the limit of 5 as x approaches infinity and the limit of 2 over x squared as x approaches infinity, and I'll subtract them. Well, imagine the graph of y equals 5. Y equals 5, horizontal line. Its limit, its only possible output, and a limit is an output value, is 5. So the limit as x approaches infinity of 5 is just going to be 5. And here I want to find the limit as x approaches infinity of 2 over x squared. You could think of that as a product. That's 2 times 1 over x times 1 over x is one way to split it up. You could also think of it as the limit of a quotient and rewrite that as the quotient of the two limits. Either way works fine. So I'll have the limit as x approaches infinity of 2 times the limit as x approaches infinity of 1 over x times, again, the limit as x approaches infinity of 1 over x. Well, the good news is we know the limit as x approaches infinity of 1 over x. We talked about it in the very first slide of the last video. As x gets, here's y equals x squared. Sorry, y equals 1 over x. As x approaches infinity, y gets closer and closer to 0. So this limit is 0. So I can rewrite this now. The limit as x approaches infinity of 5 minus 2 over x squared is 5 minus 2 times 0, or just 5. There's a second problem on your paper. Why don't you pause the video, try that out, and then you can check your answer in the next slide. You can check your answer here. That was the limit of a product. So you probably rewrote it as the product of two limits. Now that first limit as x approaches infinity of 2 times 1 over x is the limit of a product, which you could then rewrite again. And again, we happen to arrive at the answer 5, but don't worry. I'm not trying to tell you that the answer to every problem is 5. Just notice that we can, it's just coincidence. 2 5s in a row. So one more technique that's very useful for simplifying limits as x approaches positive or negative infinity is to look for terms that dominate. This is especially useful if you want to find the limit of a function that's written as a fraction. So remember the example in the bottom of the first page of your handout where you had x over the square root of x squared plus 1, and we talked about how the plus 1, as x gets bigger and bigger, the little plus 1, he doesn't have much to do with the problem anymore. It's the other terms that dominate. So try this. We're going to work on problem from your textbook, but I've modified it slightly. So I want to find the limit as x approaches infinity of this giant fraction. Here we go. So I can do this by looking for the term in the numerator and the term in the denominator that dominate. Think about this. So x is going to get bigger and bigger and bigger toward positive infinity. Which term in the numerator is going to be the most important? Which is going to have the most effect on the output? It's going to be this first term, 2x to the 5th, because that exponent is the biggest of all the other exponents. The term that's going to dominate for the denominator, again, the term with the biggest exponent, in this case will be 3x squared. So I can actually simplify this problem now, and I'll get the same answer as if I were simplifying the limit of the whole fraction, the original fraction. So look at 2x to the 5th over 3x squared. You can use algebra to reduce that. There's an x squared factor that cancels out at the top and the bottom, and I have a new problem. The limit as x approaches infinity of 2x cubed over 3. So think about that. If you let x get bigger and bigger and bigger, and then you computed 2x cubed over 3, there's nothing to stop the output value from growing and growing and growing. So this result will be infinity. So infinity, it doesn't have a limit, so we would say that this expression doesn't have a limit. You could also say the limit is infinity, but you'd have to understand that that means you're saying it doesn't have a limit. And we could make the further conclusion that if I graphed this function, it would not have a horizontal asymptote. Here's a similar problem if I wanted to find this limit. Again, I'd look for the terms that dominate. They happen to be these terms. My new expression 2x cubed over 5x cubed, again, I can use algebra to simplify that, and I get this number 2/5. Now I can try to take the limit. What's the limit of 2/5 as x approaches infinity? Well, the function 2/5 doesn't have anything to do with x. The output values don't depend on x. The output value is going to be 2/5 no matter what happens. So we could say we do have a limit, and that's 2/5. And I want you to practice being able to say that the function, this rational function, has a horizontal asymptote at y equals 2/5, because the limit as x approaches infinity of this giant fraction equals 2/5. I'm going to write it out for you so you can see an example. So thank you for your patience as technology catches up with us. I had to write this with my stylus. So I would say y equals 2x cubed minus x squared plus x minus 1 all over 5x cubed plus x squared plus x minus 5 has a horizontal asymptote at y equals 2/5 because the limit as x approaches infinity of 2x cubed minus x squared plus x minus 1 all over 5x cubed plus x squared plus x minus 5 equals 2/5.